This video will discuss future value of an annuity. Recall that an annuity is a series of payments made at regular intervals or set due dates for a length of time. The future value is the value of an annuity at a future date. For these problems, we're going to find the future value of an ordinary annuity. This means that annuity payments are made at the end of each period. At the end of every quarter, $2,250 is put into a retirement account that earns 4% compounded quarterly. Find the future value in 5 years. Round to the nearest cent. For this problem, we're asked to find the future value. We'll use the formula listed on the screen to compute the future value of the annuity. Now notice we have several variables in our formula. We have P, I, and N. P is the principal or the amount of each annuity payment. I is the interest rate per year, and N is the total number of compounding periods. The problem tells us that P is $2,250. I is going to be the interest rate per year. And remember, we find that by taking the interest rate, which is 0.04, divided by the number of compounding periods in a year. Since this is compounded quarterly, we're going to divide by 4. So 0.04 divided by 4 gives us 0.01. N is the number of compounding periods in a year times the number of years. So the number of compounding periods in a year is quarterly, so that's 4. And then we're going to find the future value for 5 years. So we'll multiply that 4 by 5. So N is 20. Now we'll take the values for P, I, and N and plug them into our formula for future value. So here we plugged in the values for I, N, and P into our formula for future value. The first step is to work within the parentheses. So we're going to add 1 plus 0.01 and we get 1.01. Next, we're going to raise the 1.01 to the 20th power. We want to leave the decimal as long as possible, so we have 1.220190004. Now your calculator might convert this a little differently because your calculator might be able to hold more digits, but you want to have at least 5 digits behind the decimal place. This is because when we get our final answer, we won't have rounding error. So keep that decimal as long as possible, and then when we get to the final answer, we'll round. The next step is to subtract 1 from that decimal. So now we're working within the brackets. Lastly, we'll divide 0.220190004 by 0.01, and that will complete our calculation within the brackets. Now we'll multiply 2,250 by 22.019004 and round to the nearest cent, which is 2 decimal places. So our final answer is $49,542.76. Assume that $250 is deposited at the end of every month into an account that earns 3% compounded monthly. Find the amount of interest earned after 10 years. Now notice this problem tells us that the amount was deposited at the end of every month. So that means that we're going to use this formula for future value of an ordinary annuity. Once we find the future value, we can then take the future value and plug it into this formula to find the interest earned. So first we'll find the future value. We need to identify the values for P, I, and N. So P is $250. That's the amount that we're depositing into the annuity. I is the interest rate per compounding period. So we take the interest rate, which is 0.03, and divide it by 12 since we're compounding monthly. And we get 0.0025. N is the total number of compounding periods. So that's the number of times it's compounded, which is monthly, and that equals 12, and we're multiplying it by the number of years, which is 10. So N is 10 times 12, which is 120. We'll take those values and plug them into our formula for future value. So here we plugged in our values into the formula, and the first step is to work within the parentheses. So we're going to add 1 plus 0.0025 together, and that gives us 1.0025. Next, we're going to raise that number to the 120th power, and you'll do this on your scientific calculator. When you raise that value to the 120th power, we get 1.349353547. And we can keep that number in our calculator and then push -1, and we should get the value 0.349353554. So you can keep those values in your calculator and then just perform the next calculation. That will save you from re-entering those long numbers in your calculator each time. So once we have this step, we're going to divide 0.349353547 by 0.0025. Next, we'll multiply that value by 250, and we'll round to the nearest cent. So when you multiply 250 by 139.7414188, we get $34,935.35. So this is our answer for future value. But recall that our problem asks us to find the amount of interest earned. So we're going to take the value that we found for future value, plug it into the formula for I, and that will be our final answer. So the interest earned equals the future value minus the total number of compounding periods times the amount deposited. So here we have I equals $34,935.35 minus 120 times 250. First we'll work within parentheses, so 120 times 250 gives us a value of 30,000. Next, we'll subtract. So $34,935.35 minus 30,000 gives us an interest earned of $4,935.35. And that is our final answer.